Welcome to Crack It. Today in this video we are going to discuss a very important topic, which is nothing but how to design an application that can handle millions of requests. So one of our subscribers wants us to discuss this question, and that's the reason we have picked up this question, and this has become a popular interview question these days. So whenever we attend the developer interviews, now we can see that design questions are also part of our developer interviews. So this question we can consider as a system design interview question or a developer interview question. So let's start the discussion. So I've decided to design an application that is going to handle a huge traffic. Then what are the things that I need to consider? So I need to consider that my applications should be scalable. Why? Because I'm going to handle a huge traffic, and so my application should be scalable. My application should perform really well, and my application should be reliable. It should not break and it should always respond when a client calls my application. So we need to consider various scenarios while designing a high traffic application. Also, let's in this video we'll just see a high level overview of how we can design our application that is going to handle a huge traffic. So the first thing we need to consider is identifying the key requirements. So if I'm going to design an application, I need to understand the requirements clearly and realistically. So I need to know what are the requirements of my application. Then only if I know my application requirements really well, then only I will be able to design that application. So I need to understand my requirements really well, and that is nothing but identifying the key requirements. Then I need to know what are the expected traffic patterns, like whether only in Saturday and Sunday it will have huge traffic, or even in the weekdays it will have huge traffic. I'm just giving an example. So I need to know what are the expected traffic patterns, what are the peak loads. If suppose Saturdays and Sundays will be my application will have huge traffic, I need to know how much requests I may get. So I need to know the peak loads of my application. I need to know in response time of my application, in how many milliseconds or seconds my application need to respond. I need to know the availability and the reliability of the system as well. So I need to know all of this. So I need to understand my requirements well. I need to know the traffic patterns and the relevant peak loads response times of my application. And I need to know how much data I'm going to store in my application, how am I going to process my data, how am I going to serve my data. So everything related to data I need to know. Then I need to know how am I going to measure and monitor my system's performance. Yes, I need to know. So because there should be some monitoring tool available for my application to get monitored, suppose say Splunk. Then only I know how my system is performing, how what is the health of my system. So I need to know how I'm going to measure and monitor my system's performance. Then I need to know the trade-offs between the consistency, availability, and partial tolerance. The next important thing that we need to consider is security. Implement, like if I'm going to develop an application, whether it's going to handle one request or 100 requests or 1,000 requests or a million requests, my application should be secured. So implementing a security measure is an essential thing for any application that we are developing. So we need to protect our application from unauthorized access, data breaches, and malicious attacks. So we need to follow a best security practices. So what in all we can do? We can implement data encryptions in our application to transform data to an unreadable format. We can have the HTTPS secure protocol implemented in our application. We can have a secured authentication mechanism, authorization mechanisms implemented to make our application secure. So if I develop any application, my application should be secure. It should be protected from any of the data breaches or any of the attacks. Also, I need to perform security audits frequently to identify whether all my dependencies are up to date or not. So I need to make sure that my application is secured in all the possible ways. So next thing that needs to come to my mind when I have to design my application is load balancing. Why? Because I'm designing an application which is going to handle a huge number of requests. So if there is a number of incoming requests coming to my application, my request needs to be distributed to the multiple servers. So who will do that? Load balancer will do that. So for any application that is going to handle a huge number of traffic, then load balancer is a must. Why? Load balancer is the one which is going to distribute the incoming request to the multiple servers. Then also we need to make sure that a powerful load balancing algorithm is implemented in this load balancer. So if my load balancer need to work properly, then I need to implement a powerful load balancing algorithm that may be a round robin or least connections or a hashing. So if my load balancing algorithm is not powerful, then what will happen again? There may be a chance that only one of my server may get overloaded. So it's really important that we need to implement a powerful load balancing algorithm to my load balancer. Why? To make sure my requests are evenly distributed. So only if my requests are evenly distributed, then only I will be able to improve the performance, availability and scalability of the system. Now I know what are the key requirements of my application. I have implemented security, I have implemented load balancing. What next I can do? I need to implement auto scaling in my application. So what, first of all, what is auto scaling? Auto scaling is nothing but we will adjust the number of instances of our application dynamically based on the traffic. Yes, my application is going to receive a huge traffic. As an example, as I told earlier, Saturday and Sunday it will be huge traffic, and on the weekends it will have less traffic. So weekends, the number of instances that is serving for my application will be less, and in the weekends the number of instances that is going to serve my application will be high. So we need to implement auto scaling in our application to dynamically adjust the number of the instances, and that is based on the traffic. So based on the traffic, I will have either 100 instances or one instance. It's completely based on the traffic. So we need to implement auto scaling in our application. So who is offering this auto scaling? Some of the cloud platforms like AWS, Google Cloud, Azure offers auto scaling features. So in our application that we are developing, in our organization, we are using AWS, and we are leveraging this feature of auto scaling. So if we design any application that is going to handle a huge request, we need to make sure that we auto scale our application. Next is horizontal scaling. Yes, we decided that we are going to do auto scaling. Next is the horizontal scaling. Horizontal scaling is nothing but okay. In auto scaling, we have two things. One is vertical scaling, and the another one is horizontal scaling. So vertical scaling is nothing but increasing the power of the server, but we need to prefer horizontal scaling in our application. Horizontal scaling is increasing the number of instances, whereas vertical scaling is increasing the power of the existing instance. So when we are going to handle an application which is going to handle a huge number of traffic, then we need to obviously prefer horizontal scaling over vertical scaling, and we need to design to scale the application horizontally by adding the required servers to the infrastructure. Also, how can we achieve this horizontal scaling? We can achieve this using the containerization techniques like using Docker or orchestration tools like Kubernetes. These two will help us to manage the deployment and scaling of the application instances. So my application instances will scale automatically up and down. So then I need to scale my database as well if required. So either I need to choose a NoSQL database which will scale horizontally, or a distributed SQL database that will also scale horizontally. So my preference should be any database that needs to scale horizontally. Also, I can implement database techniques like sharding. So sharding will help to distribute data to multiple nodes. So we can decide each shards may have like 0 to 23, like 24 instances, which may help to distribute the data to the multiple nodes. So we can implement database scaling as well when we have a huge number of traffic in our application. Next is caching. Yes, so caching is very important when it comes to improve the performance of the application. So if my application is going to handle huge traffic, there may be obvious chances that my application may be less performant. But I don't want my application to be less performant. Then what do I need to do? I need to implement this caching mechanism. What will this caching mechanism do? It will store the frequently accessed data in its cache, so there's no need for anyone. So if suppose a request comes, what will we do? We will check whether the data is available in the cache. If it is available in the cache, we will return and respond with the data that is present in the cache, and we will not go to the database to fetch that specific request or the response. So our time will get improved. So this will help to improve the response time to the client, and it will reduce the load to the database as well. Why? We are not retrieving data from the database. Instead, we are retrieving it from cache. So we are doing two important things by implementing caching in our application. One is improving the response time, and the another is reducing the load on the databases. So also, if required, we can implement distributed caching system like Redis as well for scalability. Next is asynchronous processing. It is not necessary that all my requests needs to be synchronous. So if I'm doing something to which I'm not expecting an immediate response, I can do that as using the asynchronous processing. Suppose I'm going to upload a file which has which has a huge data, that should not be a synchronous call. It should be asynchronous. I just need to push it to the queue, and I have to wait until that operation will get completed. Meanwhile, I can do some other work. So we need to implement asynchronous processing in our application to ensure that the system can handle a huge volume of requests without being overwhelmed. Yes, like it will help in lots of ways. It will improve the performance. It will help us to ensure that the system can handle a large number of requests. As in asynchronous processing will help in various ways. So also we can offload the time consuming tasks, as I said earlier, like anything like uploading a file to the queue or uploading a file to the server, like this, of whichever is a time consuming tasks, we can offload those to the message queue or the background processing. So for that, we can use RabbitMQ or Kafka messaging queue. So next is monitoring and logging. Yes, like if we are implementing any application, we need to monitor the application. So for that monitoring, we need to integrate our application to the robust monitoring applications, like we can use Splunk or any other logging solutions as well. Why? If any issue comes, we need to identify the issue by this monitoring that we are doing in our application. For we need to have a effective logging solutions as well. Why? To identify that potential issue which causes that problem. So we need to implement an effective monitoring and logging in our application. Also, if we need to implement alerting systems in this monitoring. Why? Because if suppose anything is wrong, like how we check the production defects. So for to identify the production defects, we need to have the alerting system. Then only the users of the application will get notified for any abnormalities or critical failures. So we need to have a proper monitoring, logging, and the alerting systems in place. Next, what do we need to consider? Rate limiting. There may be a high chances that a specific person is overwhelming our application. So we need to implement a rate limiting in our application to prevent excessive or abusive abuse use of the resources. So rate limiting will really help when there is a specific person or a system which is trying to access a specific API excessively. So we need to avoid that. How can we avoid that? We can rate limit our API. Next is failover and fault tolerance. If suppose something happens, if suppose let's assume the application we are developing, we are using microservices. So in the microservices, if one of these single component is a failure, we need to make sure that the other components are working really well. How can we do that? We need to implement fault tolerant mechanisms in place in our application to ensure that the failure of the one component should not bring down the entire system. So we need to implement a circuit breaker or any retry patterns or whichever pattern that is available to ensure fault tolerance in our application. Next is implementing auto recovery mechanisms. So if suppose I know that my one of my single component is down, so I need to implement a mechanism to auto recover of that simple component. Like the same thing, circuit breaker that will do this, like implementing this fault tolerance mechanism. Next is content delivery network. So we need to use a content delivery network close to our users. So if suppose my close to the users, in the sense close to the geographical location of the users, if I have huge number of users in Australia and if I have my network over some other place like US, there will be some latency. So how can I reduce that latency, and how can I improve that performance? To improve that performance, I can use a content delivery network closer to the users to cache the static assets, images, or the CSS files, or whatever it is. So if we use a content delivery network close to the users, then I can reduce the latency and I can improve the performance. So users sitting in Australia will use the content delivery network which is present in Australia instead of US. So that will reduce latency, and which will help to improve the performance. Next is global distribution. If suppose my application is going, the application that I'm going to develop will be used by the users across the globe, then it will be a good practice to use a multi-region setup of our application. So which will also reduce the latency for the different geographical users. So we need to have a multi-region setup of our application if my application is intended to serve to the users across the world. Last but not least, it is test and refine. Yes, I have implemented all the techniques that I want to implement, or that I need to ensure that my application will handle a huge load. So then I need to test the system thoroughly. So last step and the final step is test and refine. So I need to test the system thoroughly and continuously to ensure that whether it meets all the requirements, and it is performing it is performing as expected. And then I need to test whether it is properly working for the normal peaks, it is whether performing well in the load testing, performing well in the stress testing. So I need to check whether my system is working perfectly fine even if it has huge loads. Why? Because my application is going to handle such load, and I need to test whether my application is performing well during that loads. Also, we need to iterate the testing based on the feedback and metrics that has been collected from testing, monitoring, and logging. Through testing and monitoring, we will get a huge number of feedbacks, or we will be able to identify lots of defects. So based on those feedback from the various sources, we need to iterate our testing. We keep on testing our system so that it should, to ensure that it's working perfectly fine even if it has a huge load. Also, the continuous testing will help us to identify the bugs or the bottlenecks that affect the performance, reliability, and scalability. So by combining all these strategies, we can build a highly scalable and a resilient application that can handle a millions of requests effectively. So if you get a design question like this in your interview, please make sure that you try to answer this question effectively by saying all the strategies that we discussed in this video. Also, you need to if you are going to follow this for your application which you are going to design, then you should keep in mind that the specific technologies and the tools that you're going to choose may depend on the requirements of your project, budget, and expertise of your development team. Thanks for watching Crack It. If you like the content, please like the video and share it to your friends who are preparing for the interviews. Also, please subscribe the channel if you didn't already. Please like, share, comment, and subscribe for the updates, and stay tuned.